Hello, I'm Alex Heron. I'm one of the peer mentors here. I'm going to be going over a part of the OS workshop I probably should be going more in depth in, and that is explaining the booting process of operating systems or computers specifically. So to really jump into this, we're going to go over what a BIOS is, or what does BIOS even mean. So basically, our BIOS is our basic input-output system. It's an acronym. You're going to see a lot of acronyms here. So it's the pre-installed software on the motherboard that's used for modifying hardware settings. And it's stored on what is called a read-only memory chip. And this chip essentially is just a pack of ones and zeros, or current or no current. That's essentially how computers talk, or that's the only language computers could really understand. And this is for the CPU to read later when the computer is powered on. It's for the CPU to read, so then it can interface with the user and interface with the hardware that's going on. So it's more of an abstract layer to kind of connect everything together. And that chip is eventually loaded into RAM during startup, or sometimes it could just be loaded by the CPU itself. Think of it just instructions inside a chip. So what is the BIOS really useful for? So it's for changing hardware settings, like enabling virtualization. So actually a couple of virtualization settings you could change, or you could find, I think, is VT-D for Intel virtualization. AMD-V or SVM for AMD. And there's plenty of others too, I think. And the next is changing our boot priority. So this is important if we want to install an operating system, or we have a already installed operating system on a device and we want to boot into it, but we have another device that's at the top priority. So some BIOSes you'll see a kind of like a stack of like bootable devices. So like the first one would obviously be the hard drive or the SSD or the internal storage that has your current operating system in it. And then right below it is other devices. Or in the case you have no other bootable devices, there'd be no other devices in there. Unless you want to specify that you want to boot into a floppy drive or any other storage device. It doesn't have to be a floppy. We don't use those anymore. And then changing the hardware time and date. I don't know much about how that affects daily use of the computer, but I just know there is a time and dates that the computer does keep track of time and date on hardware-wise. And I think that might be important in case like something goes wrong, like it stops recording the time. I don't know. I just put that there because that's something you do. And then overclocking your CPU. This is actually a really common one if you are in the PC gaming atmosphere. Because what people like to do is they want to effectively make their CPU go as fast as possible for whatever reason. So this is totally not recommended, by the way, to do this if you don't have optimal cooling. Because if you don't have optimal cooling, your CPU might overheat, and it can cause problems. It can degrade your CPU over time, your processor. You don't want that. But essentially, you only do this if your cooling is really, really sufficient for it. And it also like uses up more power too, which I don't know, might not be good if you like to save power. And then plenty of more settings. There's plenty of BIOS settings in there that you can mess around with and play with. And yeah. So how do we access this BIOS? So if you have a laptop or a desktop, this is actually possible to access. It's possible to actually access this BIOS. It's just You just gotta know your key combinations you have to press before your computer starts up. Sometimes it'll tell you straight out that before starting up, it was like, hey, press this key to access the BIOS, or press this key to access the boot menu, which is different from the BIOS, but is good if you want to boot into another device for one time. So specific key combinations, so it depends on the manufacturer, really. There's not really any standard button you press. But here's some of the common keys to just take note in case like you're not able to like look up the manufacturer and you're not able to find anything on what specific key I have to press to access the BIOS for that computer for the computer you want to get into. These are just really common. F2 is pretty common. F12, F10, delete key, and F1. And there's actually two different types of BIOSes. There's UEFI, or the Universal Extensible Firmware Interface, sometimes shortened to EFI. This is typically used in all modern day computers, so anything after the release of Windows 8, it should have UEFI. And then sometimes, sometimes it has a fancy UI. That's how you're able to tell that's UEFI. And then, of course, we have Legacy BIOS, which actually works a little bit different behind the scenes compared to UEFI. There's not really any fancy UI for it. Usually it's a blue screen like this image down here. It has some limiting features, but they both have their benefits and downsides to them. Their own strengths and weaknesses, really. But the way they work is important because it's important to note that there's two are totally different. Only because certain the booting process could be different. Because UEFI requires one extra partition called the EFI partition in order to boot into that specific device, whereas Legacy BIOS requires a specific partition format. Well, I mean, they both require different partition formats, but they only require a specific dedicated range of values before the disk starts to consider it bootable. So yeah, that's Legacy and UEFI. Here's the image, just showing the key differences between the two. Not the key differences, but like noting how one has fancier UI than the other. What I mean by fancier too is that it also has a mouse cursor, so some of them you can actually use your mouse, which is pretty interesting. Well, the other one you need to use specific key combinations, or you use like your arrow keys, or look over here and see like what I need to press in order to do the thing I want it to do. You can do the same here, but you can also use the mouse, I guess, as an option here. And actually, also as mentioned too, UEFI does have some settings there. It allows you to turn it off, or turn off UEFI booting. Like in the case of servers, I actually seen that you can actually turn off UEFI booting and just boot into or boot a operating system in Legacy BIOS. But not all UEFI BIOSes are the same. Not all of them have fancy UI. My laptop, the one I'm running right now, does not have a fancy UI. But it should say somewhere inside of the BIOS that it is UEFI. Or you should see a setting somewhere that kind of mentions it. And again, if you have a modern day computer, you're most likely using UEFI anyways. And yeah. So now let's go over the startup process of a computer. So first, the BIOS is actually the first program that runs, even if you don't access it. Because it's really what's connecting everything together. So it kind of understands all the it connects the devices together and all that. But essentially first, the CPU reads all the instructions from the BIOS ROM. So let me just... my pen's not working. Hold on. There we go. Essentially, one of the ways is that it'll read. The CPU can read from here, or it could read from here. Essentially, what happens, CPU reads, technically, most programs, the CPU reads from RAM. There's instructions in RAM that it reads through, and in a cycle called the fetch, decode, execute, or fetches the instruction, decodes it, and then executes it, and then so on and so forth. And I think some modern day computers actually just read the ROM anyways, or read directly through the ROM instead of just reading through instead of loading it onto RAM, and then it's not really necessary for this particular video. But essentially, yeah, BIOS ran first. Okay, so what's next? Now it needs to go through what is called POST, which is Power On Self-Test, another acronym. It runs through diagnostics and builds inventory of all the installed devices before actually moving on to the booting process. So what it essentially does is it tests to make sure everything's in proper order. So like an example, if you're running your computer without any memory in it, it'll fail. It'll fail to, it won't post. So that's actually really common phrasing in the IT field. If they say it's not posting, it means that it's not able to go through that process. So after it goes through that process, then everything's good. You have all your hardware isn't messed up. You didn't forget to put your CPU in, or you didn't forget to put your RAM in. So then what's next? The booting process. So basically with booting, the whole idea is that we're handing control. So the BIOS is currently in control of the hardware, right? So now what we're trying to do is we're trying to take away that control from the BIOS and giving it to the operating system. Because now the operating system is going to be the one handling our hardware to some degree. Because it kind of needs that in order to do what it needs to do. And this is through the process of with a bootloader. So the bootloader is responsible for loading the OS into RAM so that the CPU can read it, and then telling the CPU this is where you need to start. And then here you go through the execution process of the operating system and start handing control over the slow process of handing control over to the operating system. Well, it's not slow; it's really, really fast. But just conceptually, it's really slow because there's a whole lot more to it. Even I don't understand pretty much everything about it, but there's stuff good to know. And through the boot priority, like I don't think I said this before. It's usually a stack of certain devices that are labeled as bootable to the BIOS. So that could be, again, EFI partition, or just some sort of label that actually that part of the bootloader. Essentially, is what I'm saying. There's a section of the device that handles the boot loading, and that points. Let's see if I can get a pointer here, and that essentially just points to the content of the operating system and starts it up. Essentially, what is going on? And the final process is now the operating system has full control. Now it just needs to go through the final processes that it needs to in order to actually run properly. So one of the things it needs to initialize is memory. So what it does is it pages certain parts of memory, allows certain programs to access memory, and then denies other programs from accessing memory. Essentially has to do all that on its own because the BIOS is, again, it has control now, and there's nothing else that's doing that for him, so it has to do that on its own. Devices and drivers too, it has to set that up. It has to set up some additional software that it might need to run during that process. And then also needs to run some program libraries. So libraries, essentially, some programs inside the operating system needs some sort of list of available functions or modules or anything it can run. Essentially, that's what libraries are for, kind of standardized stuff that programs would be able to run. I don't know if that makes any sense. But yeah, that's the booting process of operating systems. Hope you enjoyed this video.